So let's talk about data management. Now your first question might be, why is this important? And there's a bunch of reasons. The first one is the growth. The amount of digital information being produced is increasing at a much increasing rate. The first measurements that I saw for how much data or information was produced was by Lyman and Varian back in 2000 or 99 and 2003, and they estimated that 1.5 exabytes of unique information was produced in 1999, and that it grew to 5 exabytes in 2003. Now an exabyte is a billion gigabytes. So this was a rough estimation. Now since then, others have estimated this, and IDC, which is a consultancy, calculated that from 2006 to 2012, the amount of data generated increased from 161 to 2,837 exabytes, much faster than expected. Now where's all this data, this information coming from? A bunch of different sources. Some of the ones are the usual suspects that we all know. Facebook, 1.2 billion active daily users. That means people who use it every day. They post 300 million photos and 4.5 billion likes every day. Twitter averages 6,000 tweets posted every second. Google processes over 40,000 search queries every second on average. So a ton of information is coming from news sources that didn't even exist back at the turn in 2000 or around there. So all of this is really adding to this information growth, this data growth. But it's not just this social media. It's including in supply chains. Just look at the size here. Amazon sells to more than 400 million unique items to 240 million customers, and that's growing. Walmart handles more than 1 million customer transactions every hour, and that's imported into databases that are estimated to contain more than 2.5 petabytes of data. A petabyte is 1 million gigabytes. So that's one company. Think about UPS. They deliver every day 20 million packages and documents to more than 8 million delivery points using over 100,000 delivery vehicles. That's not even including their air. That's mainly surface. Think of all the tracking that requires and the data needed to store that. And another example, Macy's, retailer. They adjust their pricing in almost real time for 73 million items based on demand and inventory every day. Think back to the models that we developed in earlier classes about inventory and what that takes. Being able to make those decisions on millions of things all the time, that takes a lot of data. There's some other contributing factors though. Sensors. Cars today have 60, maybe 100 sensors in some of the newer ones, but that's increasing dramatically. Estimates are that it'll go over 200 sensors in each car. Now those sensors are sending information somewhere, so that's more data that's being collected almost in real time. Think of perishable items. Companies are developing smart packaging now for shipment of perishable items that captures the temperature, the humidity, all these things that might affect the goods. And these are captured while in transit, and some of the more advanced systems are transmitting that. So you think of this constant stream of data from these sensors. And then also think about the computer you're using or a server. There are diagnostic tests automatically built in those that are testing the system and sending information back to say for how well the system is operating, if any component is looking like it might fail. All of these are sensors generating ever more data about assets. The Internet of Things. These are where machines communicate with machines. There's a lot of communication between different entities, and you can estimates now are that there's over 6 billion connected things, machines in the use worldwide today, and that there are estimates that this will grow to 20 billion or more in just 4 years. And there are also estimates about how many wearable devices we have. It's not just machines talking to machines, it's also things that I'm wearing. And that number will only increase the amount of communication and data. And finally, regulations. Think about a rule that gets put in place. Sometimes that rule can generate some unintended consequences or requires more additional data or effort than initially thought. A good example of this is the 2013 Drug Supply Chain Security Act. Then this requires by, I believe, later this year, 2016-2017, serialized numeric identifiers for each item, mainly for pharmaceuticals. So let me give you an example, and I got this from an article written by Basta. Suppose that I'm a pharmaceutical company and I'm producing one batch of a certain drug, and it's going to produce 10,000 units. These are things that I would sell, the pills or capsules, whatever. Now, pre this Supply Chain Act, this would only generate 4 transactions. One saying you created the batch, another picking the pallets, second shipping those pallets, and then an advanced shipping notice, an ASN, generated for that shipment. This is roughly 2 kilobytes of data, maybe. Post this act, though, what will this require? An estimate is this is going to take 60,000 transactions now, because for every item, not just the SKU level, but each individual item now, I need to provision for this new SNI, I need to commission that, I need to aggregate that so that each of those 10,000 items that are being shipped in a pallet, I know that they're all in a certain pallet. The picking of that, the shipping, and the sending of that data, all of that is at the item level now. And so this requires roughly 11 megabytes of data, a 5,000 increase. So all of these things are increasing the amount of data that's being contributed. And so we have all of these factors that are increasing the size. However, that's not just the thing that matters, though. It's not just size, it's also the velocity and the variety. What do I mean here? Well, velocity you can think of as how fast do I need to analyze that data? Is it streaming data? So on this chart here, which comes from a great article by Rosados and Chihano, it shows the 3 dimensions here, and they really put volume and velocity kind of on the same axis, and variety on the horizontal axis, and I'll explain that in a second. But the idea here, as the volume increases, or the velocity with which you need to analyze things, that increases the complexity. But also the variety. And so you can think of the variety of data as being very structured data, where formats are set, to semi-structured, to really unstructured data. And those are on the far right. Think about call logs coming in, Twitter feeds. They're very unstructured, as opposed to on the far left, these transportation costs, very structured because they go through a financial system. And so you can think of the data here for supply chain, and they kind of fall into 3 big categories. Those core transactional data, that's that dark blue, and this is everything that's sitting in your core system that you communicate with your carriers and your vendors. Think of your CRM transactions, that's your customer relationship management transactions, your demand forecast, your transportation costs, origin destination information. That's very structured. Then I move into this internal systems data, and this is all the information, that lighter blue circle or oval, and this is things that are in your ERP, that are on your MRP, all of these things that now are in your internal systems and you're using to plan your operations. And then you've got all this other stuff. And so look at some of these things that affect your supply chain. This internet things that I talked about earlier, all that data, very unstructured. Twitter feeds, email records, call center logs, all of these things, these are all sources of data that can come in and you can use to manage your supply chain. So it's not just the volume, it's the velocity with which we can analyze it or need to analyze it, and the variety, how unstructured is it. And then finally there's one that IBM brings up and I think is really important, and they add another V, right? So they talk about the 4 V's. In addition to volume, velocity, and variety, they talk about the veracity of the data. And that's something pretty important because we tend to think if data is generated, if you see it, if it's in a database, then it must be true. And you have to question that. So veracity is another area that I think we need to concentrate on. That's what we're going to focus on for a little bit during the rest of this lesson.